In the previous video, we've managed to get our test to pass up to the point when we actually checking for the number of variants, which obviously haven't been generated yet. So let's have a look at our asset repository. And as you may remember, we added this to-do note here for these variants. This is where all the magic will happen, basically, to make sure that this line passes. So we actually generate those 8 files in this case, because obviously that's how many files we are expecting. We are running 2 requests. Each one is to generate 4 of the variants. So let's go back to our asset repository. Now here, what we're going to do is we're going to make use of a new class. It's going to be a processor type, and we're going to keep it under our processor's image. This one will take care of all image processing needs for our system. But before we do this, we will finally install our intervention image. So let's go back to the browser, intervention image. You can see the installation here. So PHP Composer require, but obviously we are using Composer globally installed. If you're not, obviously, if you're using a Composer FAR, then obviously use this approach. But what I'm going to do is simply use Composer require intervention image. It has now been installed. As you can see, I have this dependency added to the Composer. The next thing I need to do is to register image manager on the container. And if we go back to the documentation for the image intervention image, you'll see there is a Laravel integration as well, which means we need to add this provider, image service provider, to our providers. So if we open config up, and we have package service providers under the providers array, if we add this one here, and then there is a facade as well, which we can use. We won't be using this, but obviously you might use this within your application at some point. So let's just add it as well. Okay, and now that we have it all done, image manager is now available to us. What we can also do is publish this configuration file for this package. So what we're going to do is open terminal, and that will add this image config. You'll see in just a moment. There we go. It's been added here. And by default, it says that the driver is going to be GD. But what we're going to do is use env helper and specify that we want to use, if we just go back to our env, we have image driver variable available here. So let's just use this environment variable. Otherwise, the fallback will be GD. So if I want to use image magic, as I do, then obviously I can do it that way. Okay, if we can save it and close it now, now image manager is available. So the next thing I'm going to do is to create our processor class. So under the image, I'm going to create a new PHP class called image variant processor. We could actually call it just image processor, but we'll call it image variant because this is, in my case, is going to be used only for the variant generating purposes. Okay, so now the first thing we're going to do is to inject the instance of image manager. So constructor, there we go. And we want the instance of image manager. We call it manager. And let's just initialize property. It can be private. We don't need to use it outside of this class. And then we're going to create a public function called generate variants. And this method will take uploaded asset. We call it file. Then we're going to have array of variants. By default, it's going to be an empty array. And then we're going to have a closure representing the process we want to apply to all those variants. No. And what it will return is going to be an array. Let's just quickly generate some doc blocks for it. And let's say generate variants. Okay, now that we have the method stub ready, oops, not that one. I just wanted to simplify it so that the import goes right at the top here. Now what we can do is go back to our repository, and what we're going to do within our repository is to inject the instance of this image variant processor. So constructor as well, and image variant processor. We're gonna call it processor. Let's update doc blocks and initialize property. And what we're going to do here, we can now remove this to do. And we are going to use this processor. So this processor generate variance, and we're going to pass the instance of this uploaded asset, which is represented by the file variable, then the variance that we might be passing through as an argument as well, and lastly the closure representing the process, so process. Now one thing, however, as you may remember, if the file that we are uploading, obviously during this course we are working with the image, but we might also use this upload system for uploading PDF files, documents, any type of file. Technically. So if we are uploading document, we don't need to generate variance, for instance. So what we can do is use file, and we have this property that we've added there called isImage, and only then run this processor generate variance, otherwise return an empty array. And I'm just going to put it on new lines like this. So only generate variance if the file we are dealing with is of an image type. And we can save and close this file for the time being. Let's go back to our image variant processor. And inside of our image variant processor, what we're going to start with here within this generate variance method is first we're going to check if empty variance, if there are no variants specified, or file MIME type is of an SVG. If we are uploading SVG file, obviously we don't need to resize it or crop it or anything because it's a vector. So we're going to check if the MIME is represented by image SVG plus XML. If it's an SVG, we're going to return this call to the method generate sol variance. And we're going to pass just the file as an argument. So this one will generate an array of variants, but they will point to the same file as the original one without actually generating anything new. Otherwise, we're going to return this, and again, method which we don't have yet, flat variance. We're going to pass variance as the first argument, and then function, the callback, which will take a breakpoint because each of these variants will be represented by the breakpoint. By breakpoint, I mean large, medium, small, X large, or if you have any other ones as well, obviously for your application. So breakpoint, we are going to pass some data here as well. We're going to have a file variable, which we're passing through, and the process, which we're going to use as well. And here we're going to return this, again, method we don't have yet, process. We pass breakpoint through, then file and the process. So that's our generate variance method. Let's start with this generate sol variance. So if we add this method, it can be private, it doesn't really matter that much here. So this method will return array as well, because whatever we return from those methods, they has to return array eventually. So let's just generate some doc block for it as well and say generate sol variance using main file for all. And here what I'm going to do is to start with the variant. So variant equals new variant class, which we'll create in just a moment, and this class will take the path, file path, and the disk, so file disk as its argument. So let's quickly create this class. It's going to be under the assets. We create a variant. It's just a standard class, and it will take constructor with string path, and the other argument will be the disk. So string disk. By default, it will be set to null. We're going to use, in that case, the default one. And we're going to set path property to path. And then we're going to have another property called URL. This URL, which will use storage, disk, which we are passing through as an argument. If it's null, obviously it's going to take the default one set on the application, and then URL passing the path. So this way we're gonna have URL generated automatically for this as well. Okay, let's add these properties here as well, and the URL as well. There we go. URL will be of a string type. Let's just quickly add some dot block to it, that string and that string as well. And I think that's everything for our constructor. Now disk can be null as well. Yeah, that's fine. Okay, so variant class is now created. So we are able to import it to our image variant processor. Let's just organize this a little bit better. And now that we have our variant available, what we can do next is to return from within this generate sol variance this flat variance. And again, we need to pass some variance here, and this time we're going to get all the variants that we have available. So we're going to start with new small, new medium, new large, new X large. So these are the variants, array of variants available to us. And then we're going to have a callback function. So function, and then we need to use this variant that we've just created. And from here, we're just going to return it. So variant. And that's all we need from within generate sol variance. We are passing just the reference to the original file that's been uploaded. And for each variant, that's exactly what we're going to return. Now, one very important thing, when we're going to be saving this to database, this variant will automatically be serialized into JSON. And this is because we've specified under our asset, let's just open our asset model, that we want variants to be casted to array. And all variants casted to the array, what that means basically is when we pass in the array, that will be casted to JSON. When we are retrieving data from a database and then hydrating this model, it will then be converted to array. Now, JSON encodes not only arrays, but also objects. So when we have the object like instance of this variant, that will be converted to the array with path and URL as indexes. That's why you can pass the object as well. Okay, so now that we have this generate sol variance, let's finally create this flat variance method. So flat variance, which will also return array. Let's generate some doc block for it. And here we're going to say parse variance. Parse variance. I think that's it. Okay. And here we're going to start with return. We're going to put our, this isn't going to be array, it's going to be, actually, we're going to call it variance. We're going to put these variants into a collection instance, so collect variants, and here we're going to run flat map because we want to return array with index equals value, and then when it's been flatted, it's going to be just index represented by with the associated value. So function breakpoint, which comes into it will be injected to this callback use param again. That should be called callback, or should we call it a process? And let's pass it through as well. And from here, we will return this as an array. So let's just call to array straight away. And here, what we're going to do is return, and we go for breakpoint. It's index. So for instance, if we are dealing with small, our index will be SM. With medium, it's going to be MD, and so on. And then we want to run this process. So call user func process, and then we pass the breakpoint through as an argument to this process. So that's flat variant. Now we obviously need to also have this process method. So add this method stub as well. And here on this process, we are going to return an instance of the variant. And we're going to say run process. And let me explain what's actually going to be happening here. So our entry point is generate variance. We are either processing all of the variants using this process closure, or each of the variants will have its own one. So if we want all files to be, let's say, grayscale, you can have the variants just as we had them here, just new small, new medium, new large, new XL large, and then just provide a process which will grayscale all of the images. But if you, for instance, would like to resize each image separately, each variant, each breakpoint you have a separate different dimension, plus let's say one grayscale, the other one flip, and so on, then you would provide the the processor with each breakpoint. As you may remember, breakpoint has this option for the process. If we specify the width, this first argument, as a closure, we provide a closure to it, then obviously we'll be able to do whatever we want with this image for this specific breakpoint. Otherwise, we can have a global process. Let's just go back here. We can have this global process which does the same thing to all of the images for each variant breakpoint. So from here, what we're going to check first of all is going to be, we're going to create a callback variable, which will check if isn't null breakpoint process. Then we want to use this as a callback, as a process. So breakpoint process. Otherwise, we are going to use the process which came through as an argument. And by default, this process is null. So we should probably first check it, because if we don't have any process on a breakpoint and we don't have any process on this process argument, then we obviously don't have anything to do here. In which case, we're going to check if is null our callback. Then we are going to throw an exception. Throw new invalid argument exception. Process is missing. So let's just import this invalid argument exception. It's just a default PHP one. Let's just rearrange these things a little bit. Okay, and after this, what we're going to do, we're going to get the source file, so source equals, and we are going to use call user func, and we use the callback that we want to use for this particular process. Then we are going to create the new instance of the intervention image class, so manager, and it's going to be make. We're going to use file, this is our uploaded asset. We go for the file property, and then we obtain the path of it. And lastly, we are going to pass the breakpoint for which we are currently through which we are currently iterating. So the method that we're going to call this closure will receive instance of the image prepared already with this image manager, and then the breakpoint for which we are doing the performing the given operation. And then we're going to go for path equals this store method, which we'll create in just a moment. We pass the file instance, again this uploaded asset instance, and then we're going to go for the breakpoint as well. And lastly, we are going to get our source and stream it. So we get the content of it, and we're going to save it to the given storage. Now we will expect to receive an instance of the intervention image from this closure, which will obviously allow us to run this stream method on it. Let's just quickly have a look at this intervention image. So intervention image, And that should be some intervention. Intervention image. There we go. This is the instance of the class that we're going to receive, and we obviously have this stream method on it, which obviously you can have a look at what it does if you'd like to. And then the last thing we need to do is to return the instance, obviously, of this variant. So return new variant, and we are going to pass the path which we've just obtained, as well as file and the disk that we are using. Okay, so the last thing we need to do is to add this store method. So let's just quickly add that. Now here, rather than just calling it a stream, actually we can call it a stream, but what we're going to do is a type hinted is going to be stream interface, and it will return the string. Let's just add doc blocks, and we're gonna say store converted or processed image. And here we are going to go for storage put, and we're gonna use file path equals, we're gonna go for file directory. We concatenate it with the directory separators. You may remember I've added this helper with this ds method, which simply returns directory separator if you don't pass any arguments. So we are concatenating this with it. And then breakpoint, we go for index, and then concatenating this with hyphen. Finally, we have a file. Oops, not file path, file, and we get file name, the original file name. So what happens here is we're creating a new variable because we're going to use it in just a moment again, just to return it from within this store method. Actually, let's do it straight away. So return file path. So what we want to do is to use the directory on this uploaded asset file. So we have the directory which we obviously have generated here. If we just look at this directory, came from splitting this path which we passed through using this uploaded file, and we got the base directory without the file name. We are concatenating this with a /. So if the path was, let's say, image.jpg, what happens here, we're going to get image / for directory separator if we're on a Unix based systems. Then we go into prepend the index of the given breakpoint. If we're dealing with a small image, it will be SM. Then we concatenate it with a hyphen, and then the image name. So each variant will have its own file name, new file with prepended with the index of a given breakpoint: small, medium, large, X large, and so on. So that will be the file name. And then we are passing the path, which is going to come from the stream. So stream is going to be the second one, because this put method obviously can take either a string on the resource. In this case, the string will represent the resource. And then we are going to have disk. We are passing the options, what disk we want to save it to, which comes from the file, this uploaded file asset disk. And then we have visibility as well, which comes from file as well, not file path, file and visibility. And that's it for this method. So if we save it, I think we've completed the entire image variant processor. In a moment, I'm going to show you actually how we can use it, but let's just save it. And let's just run our test once more. And I can see that we are back to 133 undefined index URL. Let's quickly open our variants. I know what's happening here. We specify these properties, well, I did, as protected. They should be public, obviously, if you want to be able to serialize them. So let's try again the test. And we are still failing now. 153 line. If we just go back 153, and let's actually have a look at what's happening here. And there we go. We are expecting those prefixed names of the files, but obviously at the moment, all of those variants are pointing to exactly the same file as the original one. So we'll have a look at this in the next video.